Okay, welcome to the electrical meeting recording, or actual re-recording, because I've had to re-record this since my recording software sucks. So it's a pretty basic, just a rendition of what we went through the meeting, but without the actual meeting aspect of it, so I'm hoping it's going to be shorter. So let's just get into it. Electrical, how to blow stuff up, also known as wiring robots the right way. Setting up. Setting up is pretty simple. We only have to download one software, which is our simulator. So thanks to the talents of some others FRC students, we have an electrical circuit simulator that we can use to simulate and organize our circuits. You can download it from here. Here being a link, and it will be shared in the YouTube description. So just check the description for that. And so it's going to look like this. It's just a GitHub releases page, relatively simple. So the installation process is pretty basic. So it shows steps for each single operating system, Windows, Mac, and Linux, and it has a download on the bottom as well. But the Linux version is the jar, or the .jar file, which is basically universal because it runs on every single operating system. So if you don't, and it's also the smallest, so if you don't really want to waste a lot of space, like me, you can just download the .jar file and it makes life a lot easier. Also, if yours is not working, then you can try to use the notes over here, or you can try the .jar file and see how it works for you. Okay, let's continue. 1. Components of the robot. So in terms of the components of the robot, I like to think of it sort of as like the parts of the body because it's just a way that we sort of can think about things in a way that makes it easy for us. So it's just relatable in a sense, especially if you took biology, which I know a lot of people didn't, but whatever. So we have our heart, also known as the battery, and this is the basis of our entire electrical circuit. And so energy goes out of the battery, but it should also be returned to the battery, so it's kind of like a cycle, exactly like your heart, to be grounded. So that's kind of grade 9 science. You guys should have probably been through that. And so very simple. It's sort of like the heart, as in like the energy gets sent out, or your blood gets sent out, and then it returns back to the heart to be pumped out again in sort of a cycle. Same sort of thing here. So they're charged using a special charger, which we do have, so you don't have to worry about that. But after any competition or game, they're usually changed out to give the robot a full battery throughout the match. And the reason why I say this is because it's your battery needs to be easily removable in your circuit. So it should just take like a few seconds, not a few seconds. It should just take like about a minute or two to get the battery out and put a new one in there, so that we can get ready for the next game without having to spend like 15 minutes getting the battery out, fishing the other one, getting everything set up. So that's important. Next, we have something that's not really in the human body but still relevant, which is the breaker or the kill switch. And so this is the kill switch, and if it is toggled, which is basically this red button being pushed, it should turn off the entire robot. And the kill switch is essential for the robot, since we always need to account for error. And so what I mean by that is we need to account for the fact that the wiring may not be perfect. And if it's not perfect, so if we notice that something is, let's say, smoking up, or if we notice that there's some ticking sound that shouldn't be there, or something else, then we need to turn off the robot instantly. And so this breaker needs to turn all energy off. So no energy should be sent to the robot at all. It should be completely turned off. If a mistake is made in the wiring, it can cause damage to very expensive electrical components. And so we want to make sure that we can protect the components and minimize the damage that's done to the robot and all other parts of the robot. And so to prevent it, a breaker must be implemented in the circuit, so that's important. Next, we have our spine, because this is essentially where all the power will be distributed to all other components of the robot, and it's called the power distribution panel, also known as the PDP. And so the connectors you find over here are called Wago connectors, and they're used to power literally everything. The slots on the inside of them are for breakers, and so these breakers are just like this breaker over here, but they don't actually have a switch. So there's sort of like, if too much energy is being drawn or if too much energy is being pulled, then it's going to turn it off and make sure that there's no excess energy going to it and no major damage caused. So these are just a secondary measure, but your primary breaker should do most of the job as long as you turn it off physically. And so the top half has larger connectors, or its bottom. It really depends on perspective. This image was put in the wrong perspective, but whatever. And they will be powering the more resource-heavy parts of the robot, and they use 40 amp breakers. And so resource-heavy includes parts that draw more electricity, like motors and stuff. And so the bottom half is used for less intensive components, but it can accept up to 30 amp breakers, so it can be less than 30 amps as well. And notice how all the breakers are only connected to the positive ends, and that's because only the positive ends are drawing energy or sending energy out. Next, we have our brainstem, also known as our voltage regulator module, or the VRM. And it's pretty important because it lets us connect devices that require less amperage to the PDP without taking up crucial Wago slots. So I only have a few of these, and this is to power like devices that need less power. And so the connections that it has are called Weidmuller connections, and they're these little white things. So if we're actually in person, I would actually have to show you guys how these work and how to use them, so the Wago and the Weidmuller, but we're not, so you'll have to wait for next year. And so essentially, they can be used to power devices such as cameras, other processors like Raspberry Pis, communication devices, and sensors, etc. Just devices that require less power in general without taking up the Wago slots. So they have different voltages over here, 5 volts, 2 amps, 500 amps, 12 volts, 2 amps, 500 milliamps. Not 500 amps, 500 milliamps for the 5-volt one. Okay. Next we have our brain, or the RoboRio. And so this is the processor of the robot. All connections that are directly controlled will somehow be connected to the RoboRio. So if you think about your body and yourself, moving your hands or any other limbs of your body are directly controlled by your brain, right? So they're directly connected to the brain as well. And so all connections that send information will also be somehow related to the central processor. And so by that I mean your senses. So your eyes, your ears, on the robot it could be a gyroscope or other sensors. They all need to also be directly connected to the RoboRio to sort of function and work. The USB these guys up here are actually powered, and using them can reduce the clutter on the VRM, as USB can be used to easily power certain components, like let's say a USB camera. Let me just drink some water. Water break. I do this in meetings, so I add them to my recordings too. It just adds that level of flavor. Make sure you guys drink water. So now we have our muscles. Also known like a motor is our muscle. And so this is essentially what will move the limbs of a robot. So the limbs will be created by the mechanical team. So limbs can don't actually have to be like human limbs. They can be stuff like a lift system or a drive system or a shooting system, you know, multiple things that our motors give life to these aspects of it, right? And so they're very simple to connect as they only have 2 outgoing connections, which are positive and negative. So positive and negative. What are the implications of directly connecting this motor to the PDP? And so this question was given to the people in the meeting, and the answer is it's always going to be on. So it's essentially going to send constant power to this, right? So positive and negative will always be active. There's always energy going to the motor, it's going to always be on. So if our shooting system is constantly on, that's a bit of an issue. So we always want to make sure, we want to find a way to control our motors and make sure that they turn off when our brain tells them to turn off and they only move at a certain speed. And that's where motor controllers come in. So to control the output and speed of the motor controllers, like the one shown here, are connected to the PDP. And so the controller will also connect in some way to the RoboRio using this fancy little wire. So the red and black will connect to the PDP, this fancy wire will connect to the RoboRio, and these M plus and M minus will connect directly to the motor. So it's a lot of wires just to control how the motor will move, right? And so you can set that up in the code, or you can set it up in a way where it reads controller input and it's like, oh look, so this person's moving the left joystick in the right direction very strongly, so we should move in the positive direction with a lot of force. And so the motor controller will send more energy out to the motor to move it faster, and that's just how it works in a very basic way. And so, our Lord and Savior, which is the Falcon 500, essentially, last season, the people over at FRC made a revelation, and they were able to mix together a motor and a motor controller. I'm being sarcastic, because this has been done a lot before, and they're a bit late to the trend. And so, enter the Falcon 500. It has seamless integration with the motor controller on the inside and the motor. And so, it connects directly to the PDP and will save a lot of clutter. So, notice how, instead of having the M plus and minus, it's all done on the inside, and this only has a red-black wire, along with the fancy data cable that connects to the RoboRio. Next, we have some parts that are also not in the human body, like the kill switch, but it's a telepathy from our radio bridge. And so this is how we connect our robot to the laptop that will be controlling it. So the laptop is actually what gets all the input. So we connect our controller to the laptop, and then our laptop will send this information to the RoboRio, which will process it. So we need a way to connect them, which is our radio bridge, or our telepathy. Being a bridge, it is low power, and it only has Ethernet outputs along with one power plug. Can you guess what unit it will directly connect to? And so this was a question also given to the meeting people, and the answer is it will directly connect to the VRM. So while the VRM is connected to the spine, it directly connects to the VRM because it doesn't require a lot of power. So to save up clutter, we connect it to our VRM to sort of, make everything easier. Next, we have another thing that's not in the human body, which is the signal, or the robot signal light, the RSL. And so this light signifies that the robot is on. It is pretty bright, so please don't stare directly into it. The flashing pattern it gives out, which is essentially the speed of the flashes, send the status as well. So it sends out information as, oh, is this an autonomous? So is it being automated by the code? Is it in teleoperated mode, which is it being controlled by the human on the laptop? Right. So, and this information is crucial because we need to know what's controlling the robot. Let's say it's in a room and it's running towards a wall. We need to make sure that it can be turned off, or we need to make sure that it can be turned off by the human controller if we need to, or that the autonomous function needs to stop so that it doesn't run into the wall and harm our robot. It's crucial that you plug in an RSL since it's the first thing that the competition regulations check, and it's an important safety measure. So connecting our components, no battery. So while the battery is at the heart of the circuit, we don't want to power the circuit until we know that everything is stable. So we only want to power the circuit all the way at the end. So by the end, I mean the circuit has been triple, quadruple checked, and everything is good to go. Then we can connect it and make sure that and get our circuit running. So this is important because we need to make sure that there are no misconnections, and we need to make sure that there's no energy running throughout the battery, not throughout the battery, throughout the circuit that can damage electrical components. So you only want to connect it at the end after everything has been checked. Please emulate this behavior when designing your own circuits. It's just good practice, so let's continue. So open up the simulation software and we can get started. Our simulation software is pretty simple, so we have our new circuit, which we can, just make, and so we can save it if you want to. Help was just going to give you a list of options over here. Quit will close the menu, and so you guys can read these if you want to. And then we have our options, which is just the grid options. Clear, which will clear our circuit. Toggle panel, which will toggle this panel over here. So if you're presenting your circuit, you want to make sure toggle panel is pressed. And simulate, which will turn it on. So let's get started. Here we can open up the categories, so if you have all of them selected, it'll show all of them, or else it'll only show whichever ones are relevant. So we're only going to be working with control today, so just open that up because this is like the base of our robot, so we're only going to build a base right now. As any good robot works, we always want to start with our PDP, which is our power distribution panel, right? So this is our spine, all connections lead up from here. And in this video, or in the simulation, I'm actually going to connect the battery prematurely, but it's just to set up the simulation because it'll show red because it's not connected to the power. So we need to make sure that everything's connected, which is why I'm connecting the battery. But in real life, you can just do this by yourself. This is just to sort of cater to the needs of the simulation. So if we directly connect everything over here, we will notice one thing. Oh wait, yes, I should go over how to make the wires. So let's do that. So once you see these copper ends over here, to make a wire, you just double click on the copper end, and it will generate a wire, and then you drag this to wherever you need to, and you click to finish it. And so you can move these nodes around, but once you're done moving it, just click, and it'll end, editing it. So just do the same thing for the black one, and connect it over here. So once we do this and we simulate it, we'll realize that there is no breaker connected. And so we want to connect the breaker right next to the positive terminal of the battery because the positive terminal is where the energy is going out. So we're going to get our breaker and we're going to plug that guy in over here. So we're going to plug one end into the top, which is basically one end of the breaker. And so while this red button isn't pushed, it's going to be connected internally. When you push the red button, it's going to eject the connection, so there's no more energy being sent at all. Okay, so we're going to organize it. We're going to move these around a little bit. And I think that's good. You just change this to be straight. Okay, so now if we simulate it, everything is good to go. Okay, nice. Next, we want to connect our VRM. Yes, our VRM, our brainstem. And so to connect our brainstem, we want to make sure that it is rotated. We don't want to make sure, but it's nice to be rotated because we want these to be on this end, just to make the wiring neat. So you can rotate it by clicking this rotate button. And so you get that by clicking on here, and it pops up right here. So we want to connect it over here. So notice if you read this green side, which takes up these 4 ports, that this is for VRM and PCM power. So PCM is the pneumatics control module. Pneumatics are basically hydraulics, so things that use air pressure to work. So we're actually not connecting pneumatics yet, so we don't really have to worry about it, but we just want to connect our VRM, so we're going to connect it on either one of these green ports. So we have red, black, red, black. So we want to connect red to red, so positive to positive, and we're going to do that by just double clicking here, getting a wire, and connecting it over here. Boom. And we're going to double click here, we're going to get a wire, and we're going to connect it over here. Pretty simple. Okay, now that our VRM has been connected, we can simulate, and we see that everything is good to go. Yay, that's great news. Now that everything is good to go, we're going to connect our RoboRio, right? So I'm going pretty fast. You can slow down the video, but our RoboRio is essentially the brain, and it's going to be what controls the rest of our entire robot. So we want to make sure everything is connected well. And so our input is over here, and the top one is positive, the bottom one is negative. It's hard to see with this low quality PNG, but with intensive experimentation, I'm proud to tell you that that is indeed true. So we're going to double click this just to get this out, and we're going to connect it over here. And then we're going to format it so that it looks proper, and it looks like this. Same thing over here, we're going to move this around, and we're going to connect it over here. Then we're going to format this, make sure it looks proper. Okay, there we go. Now if we try to simulate it, we'll see that everything works well. And notice where I connected this. So this is the controller power, so it's not, so the RoboRio is not the VRM or the PCM, it's actually a controller. So this side uses 10 amperage, this side uses a 20 amperage breaker, and so this just means that, it's just a different level of power that's going to it. So it's good news. And this is basically the basis of our entire circuit. So there's the radio bridge as well, but I want you guys to try that on your own. Actually, no, I should probably explain how to do that. It's just very, very finicky. So this recording, the ending might not be perfect, but it's just because this software doesn't really work well with Ethernet. So we're going to make an Ethernet wire over here, and we're going to connect it like this. And you'll notice that it doesn't look connected at all, but it actually is connected. It's just really dumb. So if you click on the wire itself, you'll see over here connection 1 RoboRio, connection 2 to the radio. So see, it is connected. It's just really dumb, so it doesn't work. And now we want to connect our positive end to the positive terminal over here. So we're going to do that like this, and we're just going to format this a little bit. Just run it up along the top. And then we're going to get our wire over here, and we're just going to connect it over here. Pretty simple. Okay, there we go. I think we've gotten the basis. So now if we simulate the circuit, we see that everything is working and the Ethernet is somehow connected even though it's not connected at all. And that's just a brief introduction to making the skeleton of a circuit. And so you'll notice that this is not connected at all because comms are down, and you'll notice that there are a lot of things that are not fully connected except for the radio over here and a few things. So we're going to get to connecting everything together using a special wiring method called CAN in our next lesson. But for now, that's about it. I hope you guys have fun and keep it cool.